Nuclear energy in an advancing world. The most common type of nuclear reactor is the pressurized water reactor. It works by using hot and pressurized water to take heat created in the core through the steam generator. The steam line carries the steam to the steam generator, from the steam generator to the turbine generator, which turns the turbine, creates electricity, and any remaining steam is condensed into water. Pumps pump out the water into the heater and take the reheated water back to the steam generator. The second most common type of nuclear reactor is the boiling water reactor. It works pretty similarly to the pressurized water reactor. Water flows through the core and soaks up heat created by the core, which gives off steam water, and the steam water separates and the steam flows through the steam line to the turbine generator and turns the turbine to create electricity. Any remaining steam is condensed into water, and pumps pump this water into the heater and push the reheated water back into the reactor vessel. The one on the left is a boiling water reactor. So the pressurized water goes through the core and comes out here as steam water, and the steam flows through the steam line, turns the turbine, gets condensed back into water, and flows into the reactor vessel where the process repeats.
So, for energy production for nuclear, it uses uranium-235, which is an isotope of uranium, and while the fuel pellets are actually fairly small, it's extremely energy dense. So a single kilogram of enriched uranium-235 can produce 45,000 kilowatt hours, which in comparison to other fossil fuels is outstanding. And because it's so energy dense, fuel is only replenished at the reactor once every 18 to 24 months. And a single reload of that reactor, which replaced about a third of the core, costs about $40 million. But that's actually fairly small in compared to other fossil fuels, which you need up to 15,000 tons of coal per day. So, while other plants may have a higher output than most nuclear reactors, nuclear is way more efficient. A single 1,000 megawatt hour reactor requires about 27 tons of fuel per year. At the same time, a comparable coal plant requires 2.5 million tons of coal per year. So the fuel difference is ridiculous.
There are three main environmental concerns that are really related to nuclear energy. Two of them are related to the mining. The mining relates to CO2 emissions, and the leftovers of the uranium-rich mines have radium and radon, and those are radioactive, and if they leak into groundwater, it could be very bad. The nuclear waste is also just sitting in pools we have nothing to do with it, and if something happens to one of those pools, it could cause an environmental catastrophe. We try to regulate the plants to make nuclear energy as safe as possible, and do that. In the U.S., we have the Nuclear Regulatory Commission, and they regulate the facilities. They make sure all the workers are specialized and know what they're doing. They provide armed guards to protect the facility and make sure that no one breaks in or steals anything or damages the plants in any ways. They also have created several fail-safes to ensure that if something does go wrong, the situation is minimized or almost reduced to not even really a problem, because they can fix it and not have anything bad happen at all. The public opinion is mainly one of fear, and it's mostly due to disasters such as 3 Mile Island, Chernobyl, and Fukushima, which are actually due more towards human error and less towards actually a problem with nuclear reactors. The fear also stems from the fact that we originally used it as a threat of nuclear war and stuff like that, so it really turned people off from developing this technology in case it happens again. And also the uncertainty of what we're doing with the waste has concerned the public.
So, do the possibility of a meltdown outweigh the benefits that nuclear energy offers?
No. The risk of a meltdown is very small, and the few meltdowns that have occurred, such as Chernobyl, 3 Mile Island, and Fukushima, were preventable occurrences. The positives of nuclear reactors include that they're a clean energy source, they're highly efficient, and they don't require a lot of fuel.
What are some of the safety concerns surrounding the storage of nuclear waste, along with having such highly radioactive material as far as national security goes?
The main concern is that a terrorist organization or foreign powers will try to use the waste as material for nuclear bombs and other nuclear weapons. In the U.S. and most countries, the waste is highly regulated. Like, they make sure that it has guards around it, and that people have to have IDs to get in, and that they try to minimize the amount of people who have access to it and ensure that it cannot be used for illicit reasons.
So, nuclear energy has many positives. It's it's a very clean energy source. The only real CO2 or greenhouse emissions come from the mining of the ore, and even then, it's significantly less than other forms of fossil fuels. And the actual nuclear reaction itself produces no greenhouse emissions. The energy source is highly energy dense, and you could get significantly higher kilowatt hours over most other energy sources. So with that, nuclear is a very plausible long-term energy source for the United States in the near future. Thank you.